Hi guys, so you should have your do now out in front of you and you should try each of these, pause the video, try them, and then when you're ready, hit play again so you can check your answers with what I have up here. Also, the homework from last night, the answer key is posted to Teams, so you should be checking that on your own time as well. So pause the video, try the do nows, and then hit play to check your work. So I set up my polynomials with a placeholder in that second polynomial because it was missing the x term. So instead of x squared minus 2, it should say x squared plus 0x minus 2. So when I go to use the tabular method, I'm going to have a 3 by 3 box. My first row should say x to the fourth plus 3x to the third plus 1x squared. My middle row is a placeholder, so they're all going to be zeros, but I like to keep my variables and exponents nice and organized. So this is going to be a 0, x to the third, 0x squared, and a 0x. And then my last row should be negative 2x squared, negative 6x minus 2. Remember, the reason we use the placeholder is because then on the diagonal, when I'm adding, my like terms line up. So this diagonal is x squared terms, and my last diagonal is linear or x terms. So my final answer should be x to the fourth plus 3x cubed minus 1x squared minus 6x minus 2. Remember, once again, if you didn't use the placeholder, you're going to end up with the same answer, but starting today when we go to divide, it won't work. You'll get stuck. And then your second do now, you're dividing your coefficients, so you should get a 2. And when I'm dividing my exponents, I'm subtracting them. This has an imaginary 1, so my final answer should be 2x squared. So our target at the end of 42 minutes, I can divide polynomials using the tabular method. So we're going to watch this video. You're going to follow along and take notes. Pause as you need to. There are certain points in the video where I'm going to ask you to pause and try something on your own. And then after you try it, you can hit play. You can always rewind if you miss something or pause if I'm going too fast for you. So just some vocabulary. A divisor is the number or term that you are dividing by. The quotient is the answer you're going to get when you're dividing. And then the dividend is the number or term that is being divided. So there's a lot of words here that may not be familiar. Hopefully at least quotient is familiar. So I have just some pictures for you. In case you're more of a visual person, you can copy these down into your notes to help explain what each of these 3 vocabulary words are. If you need to, hit pause, and then when you're ready, you can continue. My next vocabulary word is factor, which is something that divides into a polynomial or a number evenly, meaning there's no remainder. And then my last vocabulary word is a remainder, which is the number or term left over when you're dividing. So here's our first example. We're going to divide 2x to the third plus 15x squared plus 27x plus 5 divided by 2x plus 5. So I am going to set up a tabular method. I'm going to, normally when I multiply, I use the top and the right. This time what you end up with on the top is going to be my answer or my quotient. You're going to put your divisor on the right side. So because I'm putting a 2x plus 5 on the right side, my table or my tabular setup, my box method, has to have 2 rows. And then your dividends is going to go on the diagonals. This top piece is going to go on the diagonals. So I have my 2x plus 5 set up on the right. Remember, this is my divisor, and then my dividend goes on the diagonals. You are always going to start in the top left corner. Okay, so this diagonal has to total to 2x cubed. The only way to do that is for that to be a 2x cubed because there's nothing to combine with. It's only one box. There's no diagonal to add on. So I'm looking for the top piece here. I want to know what times my 2x gave me 2x to the third. I'm looking for this piece up here. So I should have an x squared because x squared times 2x gives me 2x cubed. After you have a top piece, you're going to multiply. X squared times 2x is already in my box, 2x cubed. Now I'm going to do x squared times 5 to get 5x squared. Now, this diagonal here has to add to give me my output of 15x squared. So if I already have a 5x squared, that means that in my top middle, I have to have a 10x squared because 10x squared plus 5x squared would give me this 15x squared. So now I need the top piece. What times 2x gave me 10x squared? It should be a positive 5x. 5x times 2x gives me 10x squared. I'm going to continue multiplying. 5x times 5 gives me 25x in the bottom middle. Now once again, I go to my diagonal. On my diagonal, I need to add to give me 27x. I already have 25x, so this top right needs to be a 2x. Now I need to go to the top. What times 2x gave me 2x? A positive 1. So 1 times 2x is 2x. That's already there. 1 times 5 is 5, which is my output here. So I'm good to go. So my answer or my quotient is x squared plus 5x plus 1. If you need to, pause, rewind, and then ready to go in your own pace. The number of rows and the number of columns, you're going to have to learn how to set it up because I set this one up for you and I'm going to set the next one up, but then you're going to have to learn. So the divisor is always going to determine your rows. So one more than the largest exponent in the divisor will give you your rows. The columns is one more than the difference of the largest exponents between the top and the bottom or the dividend and the divisor. This is my numerator and my divisor is my denominator. Okay, so let's go to the next example. I already have it set up in terms of the box. My divisor goes on the right side. So this is x minus 2. Then my dividend or my numerator goes down the diagonals. 2x squared plus 1x minus 10. And I always start in the top left because that top left box has to match that diagonal of 2x squared. So I ask myself, what times x gave me 2x squared? It should be a 2x. As soon as you have a top piece, you multiply. 2x times x is 2x squared. It's here. 2x times negative 2 is a negative 4x. This diagonal has to add to a positive 1x. So I need to have a 5x because 5x plus negative 4x is a positive 1x. So what goes up top? What times x gave me 5x? A positive 5. Once you have a top piece, you multiply. Even if you already have your answer, you want to keep following through. A, to make sure you did it correctly and it matches. And then B, as we get into some of the problems later on in the packet, they're not always going to match. You're going to have a remainder. So 5 times x is 5x. 5 times negative 2 is negative 10. I match. So the quotient is 2x plus 5. Please make sure you write your answer to the side and box it. You can't just leave it as this tabular method because now I don't know, was I multiplying, was I dividing, which piece is my answer. So get in the habit of always writing your final answer. So I want everyone right now to try this one on their own. Try to set up the box. Hit pause, set up the box, hit play, see if your setup matches, then hit pause again and actually try the division. So check your setup. My d of x is my divisor, so that goes on the rows. So I need to have 2 rows because I have an x and a minus 1. My f of x is my dividend, so that goes down the columns. So I need to have 4 columns. If I'm going by the rule that we talked about before in terms of determining columns and rows, my columns is 1 more than the difference of the largest exponent in the dividend and the divisor. So to determine the columns, I have a 4x cubed divided by x, which means I'm going to get an x squared term. So this number plus 1 gives me my column. So I need 3 columns. Okay? If you have it set up correctly, pause again, try the dividing on your own, and then check your work. So you should be checking your work now. I'm always going to start in that top left corner. 4x cubed. What times x gives me 4x cubed? 4x squared. I have a top piece, so I multiply. 4x times x is 4x to the third. 4x times negative 1 is a negative 4x squared. That diagonal needs to total to this output of negative 2x squared. So I need to have a positive 2x squared. What times x gives me a positive 2x squared? A positive 2x. I have a top piece, I multiply. 2x times x is 2x squared. 2x times negative 1 is negative 2x. This diagonal has to combine to give me a positive 1x. So in my top right, I need a positive 3x. What times x gave me a 3x? A positive 3. Now I multiply. 3 times x is 3x. 3 times negative 1 is negative 3, which is my output. It works. My final answer is up top here, 4x squared plus 2x plus 3. So hopefully you got it correct. If not, pause, make your corrections. When you're ready to go, hit play again. Example 4. Use the tabular method to find the quotient of 2x to the third minus 51x plus 5 divided by x minus 5. So 2x to the third minus 51x plus 5 divided by x minus 5. I have to be careful here. Hopefully you notice that you need a placeholder. Just like with multiplying, I skipped over that squared term in my dividend or in my numerator. So I'm really going to write this as 2x to the third plus 0x squared minus 51x plus 5 all over x minus 5. Hit pause, try to set it up. Once you have the setup, hit play, check your setup, then hit pause and try the problem again. Here's your setup. Once you have it set up, hit pause, try it on your own. Then hit play and check your work. Always starting top left. 2x cubed. Up top, I get a 2x squared because 2x squared times x gives me this 2x to the third. From here, I'm going to continue filling it in, but I'm going to do it silently. If you have a question, call me over and I can explain it to you. So my final answer is 2x squared plus 10x minus 1. If you need to, pause or rewind, make corrections, and then you can move on. Example 5, this time you should notice that first of all, I have an x to the fourth, so there's going to be a lot more terms, but I'm checking for placeholders. My divisor or my denominator needs that placeholder. My numerator is okay. The dividend does not skip over any terms. My divisor, however, skips over the 0x. So this is how you should have it set up. So now my divisor is squared. So I have my rows. I'm going to have 3 rows. For my columns, I have an x to the fourth divided by an x squared. That's going to give me an x squared. I have to add 1, so I'm going to have 3 columns. Hit pause, set it up, check the setup, hit pause, try the problem. Here's the setup. If you're good, hit pause, try the problem on your own, and then check your work. Remember, this middle row should be a 0 because I'm multiplying by 0. It happens to be a 0x cubed in this case. I'm filling in that entire column. As soon as you get that top piece, fill in the entire column by multiplying. Now I'm looking at this diagonal. It has to add to give me a 4. I have a 0, so this one's easy. I know it's going to be a 4x to the third. So up top, I should have a positive 4x. Now I'm going to multiply. 4x times 0x is 0, specifically a 0x squared. 4x times 1 is 4x. This column, all 3 of them have to add to give me a 3x squared. Right now I have a 1x squared and a 0x squared, so this is going to be a 2x squared. Top piece should be a positive 2. Now I multiply. 2 times x squared is 2x squared. 2 times 0, 0x. 2 times 1 is 2. Check that both of your extra columns line up. 4x and 0x works. 2 works. So my answer is x squared plus 4x plus 2. Hopefully by now we're getting the hang of this. So what I would like you to do is I would like you to try this one, example 6, and example 7 on your own. Pause the video at this point, do both of these problems. When you're done with both of them, hit play and you can check them. 2x squared plus 5x minus 3 over x plus 3. I don't need any placeholders. I'm going to have 2 rows because I have x plus 3. My columns, I have an x squared term and an x. It's going to give me a linear term or an x to the first. So I add 1. I have 2 columns. My diagonal, 2x squared plus 5x minus 3. Start in your top left corner. My top piece is 2x because 2x times x is 2x squared. I continue multiplying. 2x times 3 is 6x. My diagonal has to add to a positive 5x, so this needs to be a negative 1x. My top piece has to be a minus 1 because minus 1 times x is negative 1x. Keep multiplying. Negative 1 times 3, negative 3. It checks out. My quotient is 2x minus 1. That's number 6. Here's number 7. 3x squared minus 13x minus 10. And my denominator or my divisor is x minus 5. I don't need any placeholders. Once again, I have 2 rows. Remember, your rows come from your divisor. This has an imaginary exponent of 1. So my rows, I have an x to the first. 1 plus 1 gives me 2 rows. X minus 5. My columns is when I divide the largest. So I have an x squared or a 3x squared in my numerator and an x. I'm going to end up with an x to the first, 1 plus 1, 2 columns again. My numerator, which is my dividend, goes on my diagonal. 3x squared, negative 13x, negative 10. I always start in the top left because this column has to be a 3x squared. I go to the top. I should have a 3x up top because 3x times x gives me 3x squared. I'm going to continue multiplying. 3x times negative 5 is a negative 15x. This column has to add to a negative 13x, so this is a positive 2x. Up top, I have a positive 2 because 2 times x gives me 2x. 2 times negative 5 gives me a negative 10. It matches my output here. My quotient is 3x plus 2. Okay, from here, let's take a look at example 8. This was a Regents question. It's a dividing question, but they ask it a little differently. Algebraically determine the value of h to correctly complete the identity stated below. So this is what I'm looking for. I don't want to have to sit here and use the box method on the right side because I have multiple variables. So instead, I'm going to divide by 3x minus 2. But I know that if I divide on the right side, I have to divide on the left. So now I'm going to use the tabular method to divide. Okay, so if you feel confident at this point, hit pause, do the division on your own, and then hit play to check your answer and find the final answer of h equals, because that's what my final answer needs to say. I don't have any placeholders here. I'm going to set it up. I have 2 rows, 3x minus 2, and I have 3 columns. Columns, once again, come from my largest exponent in each piece. So an x cubed divided by x is an x squared plus 1. I have 3 columns. My diagonal should say, let me erase this so I can see what's happening, should say 27x to the third in the first one, a positive 9x squared in the next one, a negative 3x, and a negative 10. Start in my top left, 27x to the third. Up top, I should have a 9x squared. 9x squared times 3x is 27x cubed. Keep multiplying. 9x squared times negative 2, negative 18x squared. My diagonal has to add to a positive 9x squared. So that means that I have to have a positive 27x squared. So up top, I should have a positive 9x because 9x times 3x gives me 27x squared. I continue multiplying. 9x times negative 2, negative 18x. This needs to add to a negative 3x. So I should have a positive 15x. Up top, I should have a positive 5 because 5 times 3x gives me 15x. Continue multiplying. 5 times negative 2, negative 10. That's my output. So that means that my quotient is 9x squared plus 9x plus 5. They did not ask for the quotient here. They asked for h. Okay? If I take a look at the right side, they have h in front of the x. What do we have in front of the x in our answer? We have a 9. So that means h is 9. Okay? At this point, hopefully you feel better about this. We're going to continue practicing. The practice problems we'll do next class, so don't worry about that right now. If you have a question, call me over. If you're done, you can start your homework at this point.